Alright, welcome back to Section 4 of the Scrape the Planet course. I'm your instructor, Mitchell Edwards. If you haven't watched the last couple of videos in this section, you're frankly going to be fairly lost. We've built out a pretty large spider that is going to solve the Kevin Bacon problem. If you aren't familiar with what that problem is, a quick Google search will kind of reveal that, or you can go back and watch the last couple of videos in this section. If you're watching this on Udemy, obviously it's just the last couple of videos in the section. If you're watching it on YouTube, I'll link to the playlist and all of that fun stuff to make it a little bit easier to find. So in the last video, we talked about local caching and local cache checks specifically, and how they can really speed up your scraper and minimize the amount of external requests you make. So we're going to actually implement that here. Now, instead of, the last couple of videos, I've kind of written out the code live and have, struggled through a couple of parts because, that's just programming. In this part, I've already written the code. I'm going to copy and paste it, and I'll walk you through exactly what it is that we're doing. I just don't necessarily see the benefit as much in watching me code it live, watching me make mistakes, all of that. I mean, it's good to know that, everybody else makes mistakes, but it's not necessarily the most useful thing in a class. So instead, I'll go ahead and just copy over the code itself, and then we'll walk through it. So there are two functions. We are currently caching movies. Let's see if I can find it. So we're caching actors right here. This is our function that we're using to cache actors, and we're caching movies right here. Now, since we are caching those two things, we want to be able to retrieve them, or at least to retrieve specific pieces of data from them. There are basically two pieces of data that are very important to this spider, and that cause a lot of requests. So the way that you would find that out is basically to print out a log or to save a log every single time a request is made. So go through all of your functions, find which ones are implementing like request.get or request.post, and make a print statement like such and such, such and such function is making a request to this web page. And that's going to kind of show you which functions are creating a lot of requests within your code, because a lot of times that can get kind of convoluted over time. And when you realize, just how many requests you're making externally, that's where you can actually start minimizing those external requests by using local caching. So we're going to copy over a getActorCache function, and that is going to basically be the read version of our ActorCache function. All right, let me copy and paste that over, and we'll put it actually right above the actor or the ActorCache function, kind of keep everything grouped together so it's a little bit easier to find. So put that right here. So now we've got that. Should be good. Shouldn't really need to change too much since these are functions that kind of live on their own. And we'll get the get movie cache function. So all of these are functions that I wrote before. I've tested them. They should theoretically work. But again, you know how programming works. Nothing actually works the way that you want it to the first try. So there might be some bugs we've got to go through. But we're going to go through the functions themselves anyway, so I should be able to spot at least some of these bugs. So let's look at the getActorCache. So basically what we're wanting to do here is, if you look at our query right here, this is the main query that we're going to be running. We're looking for the actor's link and the list of movies that the actor has been in. So the reason there is that's the request that we're making very frequently. We're having to reach out and find an actor's link fairly frequently within our loop. We're having to reach out and retrieve a list of movies from an actor. So instead of doing that externally every single time, we're going to check and see if we've got a local cache of those two pieces of data. So up here, fairly basic, we're making sure that we clean up our name. There were a couple of instances where the scraper was pulling in the name weird, and I didn't really want to go through and debug why that was happening, so I just went ahead and cleaned up the name by default. We're creating our connection with our database here, fairly basic stuff, and we're initializing our actor link variable and our movie list variable, because if we don't have a local cache of the data that we're looking for, we're going to return an empty actor link and an empty movie list, and that's going to tell our code, hey, you're going to have to reach out and grab this from the web. So that's why we're initializing them to empty up here. Fairly important there. Right here, we are writing the initial query to make sure that the actor data table is actually created. If it's not, it's going to go ahead and create it. I could probably write in some, basically some logic that says if this query runs and successfully creates the table, meaning the table did not exist before, then go ahead and exit, because obviously we're not going to have a local cache of anything. I would do that if I were writing this in prod, but it's not super important, and we're not just incredibly worried about, you know, the utmost efficiency there. We're just trying to understand the concepts. So here's where we create our query. We are selecting the actor link and the movie list, so those are the two pieces of data that we're interested in, from the actor data table, where the actor name is equal to this string, and that string is what we pass through right here. So we are searching on the actor's name. So when we run this function, that's going to be the variable that we pass to the function. So we're going to execute that query here, and it's going to put name into that %s. That's what that string formatting does right there. So this is the first time that we're doing reads from Postgres in this series, and basically the way it works is you execute the query, and then you use the cursor to fetch all of the results. If you're using, like, for example, a limit 1, so if I did this, that means it's only going to return one single actor, even if there are multiple actors. Now, theoretically, this would probably be a more efficient way to do it, but it doesn't really matter all that much, because there should only be one version of the actor in the list at all times, because the actor link right here is the primary key, and there should be a direct mapping between the actor name and the actor link. But that's not always the case. There might be some weirdness where there are 2 or 3 Joe Smiths that have different actor links, and in that case, we're going to fetch all of the results. We are going to set actor link like essentially equal to the last one in the list. So if there are 3 Joe Smiths, we are setting the actor's link equal to the first one, then the second one, then the third one. So this is going to end up being the last actor in that link. I should probably actually throw in limit 1 here. That way we're only grabbing one. But I don't know if that's going to break fetch all. So I'm just going to keep it as is because I know that it works. And we'll just acknowledge that there are going to be some edge cases where this gets borked up. So we're going to go through every row. That's the way the actual results within this query are organized. They're organized in rows, just like they are in the actual table itself. And it's automatically split based on the column. So the actor link is going to be the first item within the row, and the movie list is going to be the second item in the row, since that's the order that we're passing this in. So then we're going to iterate over all of the items within the list. We're going to make sure that we clean them up. We are going to split them. I actually don't really know why we're doing it that way. Oh, because so each item basically looks like this. So I'll write a comment. Item is equal to, I think it's a tuple, if I remember correctly. So we're removing the parentheses there, and we've got our name and our link here. So again, that's an area where I could have done this more efficiently by explicitly making this like the right kind of array and, you know, passing it in correctly and all of that fun stuff. I didn't do that, so we're kind of having to pay for it here with a slight dip in efficiency. So we're having to split it right here. So basically this is going to split the item into this. So we'll have our name here and our link here. And then our name is going to be the first item in the list, obviously right here. And then our link is going to be the second item in the list here. And it will create our movie object right here. We're going ahead and cleaning up the name. I think there were a couple of instances where I had stored it weird, so we're cleaning it. Really, I've found that the dip in performance that you get from running these strips, from actually like stripping out like the weird characters and all that, you don't get that much of a dip in performance if you're doing like fairly small or medium-sized projects. So I don't really worry about like just peppering this everywhere and just to clean up the actual names and things like that. It does end up helping later on, just because sometimes these weird characters end up in strings that you wouldn't expect them in. So if you go ahead and explicitly strip them out every single time, you're worried about that, then you don't have to worry about it as much. So we're creating the object, and we are appending that object to the movie list that we're going to return over here. So this movie list is going to be a list of actual objects. So these dictionaries right here. Okay. So that's really all that there is for the actor cache. Basically, the actor cache, if we find the data that we're looking for in the table, is going to return our actor link, which is just a string, and our movie list, which is a list of dictionary objects. So let's move on to our movie cache. And you can actually see right here, as I was saying before, the movie objects that we're passing in as an array are basically just tuples. So that's the way that we're doing that, and it's stored as an array of strings instead of an array of tuples. I think, fairly certain that's how it works. So the get movie cache. So what are we looking for in the get movie cache? We're looking for the actor list, and that's one of the things that we're actually querying for fairly often. So the situation there is, okay, I've got this movie, I want to see what actors are in it. Instead of, by default, reaching out to the external IMDB website, sending that request, waiting on the request to come back, processing that request, caching it, and blah, 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 we're instead going to first check and see if we've already got that movie cached. And if we do, we're going to go ahead and return the list of actors. So fairly similar thing here, creating our database connection, executing the query, and we're executing this query based on the movie link, since that should be unique for every case. So we're passing in the movie object itself, and getting, passing just the movie link parameter to the query. So that's going to place this movie link right here. So we're basically saying select actor list from movie data. So select the list of actors that are in the movie where the movie is equal, or the movie link is equal to the link that we pass in. So we're going to grab the rows and iterate through the rows. I wrote a print statement just to say that we found the movie, so it was cached, and our result is the row at 0. So that's going to be the actual actor list itself. We're going to cycle through all of the items within that list, and we are going to strip out the name, link, and create an object within the actor list dictionary that maps the name of that movie, or the name of that actor, to their link. So the return there is going to be a list of actors based on their names, so a dictionary of actors with their names mapped to their links. Very, very useful, and we'll see down here where we're going to implement it. Basically, where we're going to want to implement it is, let's keep in mind what data that we're fetching here. So we are fetching, caching an actor list. So that's what we're grabbing from the get movie cache. And I'm going to close out some of these functions just so it's a little bit easier to scroll up. And we are fetching actor links and movie lists. So let's go down here. Actor link and movie list. So that is the data that we're actually able to fetch from our cache with these functions. So basically any place where we need that data, we're going to go ahead and check for it. We could even check for it up here at get actor link. So we can use this as kind of an example. So let's do actor link movie list is equal to get actor cache. We are going to pass in the actor's name. So that is just actor. So then if actor link is equal to an empty string or movie list. Sorry, I've been writing in, I think it's, there's several different languages that I've been writing code in that all do length differently. So movie list is equal to 0. So if we don't have that local cache, then instead this is going to be what we do. So this line we should be running either way. Both of our prints actually we should be running either way. And basically the way that we're doing this is we're going to check the cache first. If we don't find it within that cache, that's going to be when we actually go to these functions right here that make that external request. So that's essentially our first implementation of checking the local cache first. So basically that kind of also gives us a really easy way to search for places where we need to implement this. So basically anywhere where we are calling get actor link, we need to check the cache first. So let's do a search on get actor link. So right here, I'm just going to make note to do check cache here. We've got one there. That's the function definition. We're already checking the cache there. So really there's only one other place that we can do it. We also have this function that we can check the local cache for. And we've got a place there. Check local cache. So there, that's function definition, and we are already checking cache there. So there are really only two places where we can use that get actor cache function instead. So we've got our check cache here, actually and basically in two very, very like close places right here. So what we can do is we can implement it once up here. So actor underscore link and movies is equal to get actor cache with the name of the actor right there. And then if actor link is equal to that, or length of movies is equal to 0, then we're going to reach out and actually grab this stuff. So we can basically just indent both of these and we're donezo. So that's two different places where we are now checking our local cache. Now, so that's just for the actor, and now we've got the get actor list. So that function is another one that we want to check the local cache on. So let's look for that function. Let's see what I called it. Get actor cache, get actor list. Yeah, and that's one based on movies. So anywhere where we do get actor movies, we want to check the cache first. And let's do movies is equal to, what's it called? Get movie cache. And we're going to pass in the actor link. Oh, no, I'm doing the wrong function. Sorry about that. So we are instead looking for get actor cache, get actor list. That's what we're looking for. Get actor list. Okay, now I know what I was doing wrong. So there are actually 3 places it looks like where this is being called. Well, no, it's not. So it's probably 2. Yeah, so we've got one right here. So that's the additions. So instead of, basically what this is doing is it's checking for the actor list of this movie right here. And the context is relatively close to where we started our actual like current depth, our current level of depth. So it's a fairly important place to do this, and it's actually going to save us a lot of time. So additions is equal to, instead of get actor list, we're going to do get movie cache, and we're going to throw the movie object into it. And if the length of additions is equal to 0, so if the length of additions is equal to 0, then we're going to make additions equal to the external version of that. So we're actually going to reach out to the internet and look for it. So that should be the only place that we can really implement that. I guess we could implement it right here, actually. So actor list is equal to, it is get movie cache and passing in the movie object. And then if that's empty, if length of actor list is equal to 0, then we're going to reach out and grab the big version. So that should be the last place that we can really implement this, I believe. So let's watch and see how much faster this is. We've got, let me go back and check my table. And let's see how many objects we've got within these two tables. So Postgres, PSQL, we're going to connect to the test DB, and tables. We've got 3 different tables. The stock data, I believe, is something that we're going to go over in the next section. But the actor data and the movie data is what we're interested in. So select count from actor data. So we've got 2,200 actors scraped in there. And let's do the same for movie data. And we've got 58 movies. So that's fairly good. We've got a fairly large local cache. And like I said in the last section, we're going to continue caching things as time goes on. So this is actually going to start running faster because our local cache is going to grow as time goes on. So let's go ahead and give that a try. Let's get our terminal open, and I will make it a bit bigger. So we're going to do Python s4 underscore p6.py. And we're going to run it with Jason Statham because that's what we've been using before. So watch how fast this starts moving. We're just running through movies right here. So we're like really just flying through them. This is way, way faster than we were doing it before because every single time we hit an actor, regardless of whether or not we had seen them before, we went ahead and reached out to reached out to the IMDB website. So this is showing us how many cached actors we've got. All of these cached actors would have been a separate request that takes anywhere from like 2 to 5 seconds. So we're saving tons and tons of time just by doing it this way. So you know, every time you see, it's actually going even faster than I can kind of read. So found movie transporter 3. So that means that we looked in the movie database. We found transporter 3. Sorry, and we're finding these actors. So Timo Diergaes, Oscar Relier. All of these are actors that we had cached already. They all would be individual requests if we were doing this without the local cache. So we're saving tons of time, and we're not making those extra requests to the websites that would have really pissed off a lot of website administrators. We got an error here. Looks like, that's a weird one. Probably go back and check on that later, but it seems fairly rare that we're getting errors like that. And we actually just ran through an entire level of depth in just a couple of seconds, like lightning fast. Before, it was taking me like an hour probably to get through a level of depth. So this is like wicked fast that we're actually running through all of this stuff. And eventually we'll start getting to a place where we haven't checked a movie or we haven't checked a particular actor, and it'll start caching those things and slow down a bit. But the next time I run this, it's going to be even faster. So that is local cache checking. Really, it's I put it later on in this section just because I wanted to show how to do it wrong. Because local cache checking, if you're caching stuff, if you're storing data, you should be referencing that data to, you know, make your spiders more efficient anyways. That should be basic and built in from the beginning. but I did want to show why you want to build it in from the beginning and how much faster it runs, because you can see we're really just flying through actors right now. So this is why. This is one of the biggest kind of, very easy things that you can implement within your scrapers and your spiders very, very quickly, and that should be in there from the very beginning, especially if you're storing data. So thank y'all so much. This is probably the last video that we're going to do on IMDB. We're going to move on to a very quick and easy spider on Wikipedia next. I'll explain why we're doing it that way, and we're not going to spend as much time on like the design, because we kind of spent a lot of time on the design here, and you should kind of understand that already. So we're not going to go re-go over the design of the Wikipedia spider. We're just going to kind of talk about it a little bit in the very beginning of the video, and then we'll go ahead and write it all out, start storing data, and start spidering Wikipedia, which actually is a lot of fun if you haven't done it before. Thank you so much. Take it easy. See you in the next video.